Okay, I am doing example problems from 10.2. I'm going to do number 16 right here, and then I will go over proof 26, which are not a part of your homework. But they should give you an idea on how to do the rest of your homework. So, number 16 to start with. So it's a triangle. So I always like to start with drawing a picture first. And they tell us that these two lines are parallel to each other, which means that we can use our new theorem, Theorem 55. Don't forget about the corollary on the back page here, 356. We're going to use the corollary. The corollary states that this side over this side equals this side over this side, or this side over this side equals this side over this side. So since we could do it either way really, but since x covers this whole side, we're going to set it up like this. So again, it's this whole side, so I have to combine 4 and 6. Gave me 10. And then I'm going to do 3, and then again this whole side, which is x. Now I do some simple algebra. Get the x, multiply the x to both sides. 3, then x equals 30. Sorry, keep the 4 over here. And x equals 30 divided by 4. Which means x is 7.5, if I'm correct. Double check on my calculator. 30 divided by 4 is 7.5, so we are good. So next is number 26, which is a proof. Like here. So triangle NML and rectangle IEBM. That's just our given. So we have to use what we know about rectangles to get us to use our theorem that we learned today. So, and start with drawing a picture again. Something like this. This is not exactly to scale, but that's okay. It's just for us to have some type of visual while we go through this proof. Okay, so they give us that given is triangle NL and rectangle IEB. And we are trying to prove NI over IM is equal to MB over BL. So if we look over here, we want this over this is equal to this over BL, this. So first thing we're going to do is we're going to take our given and we're going to find out as much information from that given as possible. So we don't really know much about the triangle, right? If we knew that it was isosceles or equilateral or something like that, we could use that. But we don't know that, so we have to go over to what we know about IEBM, which is that it's a rectangle, which means that it's a parallelogram, right? So this right here is a parallelogram. Yeah, why don't we say that? IEBM is a para. I'm just going to abbreviate for now. That is definition of a rectangle. Okay, so next what we want to, what we know about a parallelogram is that the opposite sides are parallel, right? So I know these two are parallel, and we know these two are parallel. Question is, how is that going to help us prove that? Our theorem states that that these two lines in a triangle have to be parallel. So we're going to say IE equals is parallel here, right? So IE is parallel to ML, and EB is parallel to MN. EB parallel to MN. We can just use definition of parallelogram. Okay, so using our theorem, we know that NI over IM equals NE over EL, and that NE over EL equals MB over BL. And this is theorem 55. So if we look here, right, NI over IM equals NE over EL. If you look, that's what our theorem here is saying, right? AB over DB is equal to AE over EC. So that's how we got this, theorem 55. And then from here, it's just using our equivalent properties, right? Because we have to get to here. NI over IM equals MB over BL. So we see that both of these share the same ratio here, which means that these two are going to equal each other. And we know this through the transitive property. There you go. So this is a 5-step proof. Pretty straightforward. So again, you'll just need to use your knowledge that we've accumulated over the year, plus all your proofs are going to use theorem 55 or a corollary or the corollary of theorem 55 in that proof to get you to your final step here. So yeah, pretty straightforward.